Why is the Windows paging file critical for performance? Imagine your computer is a busy office. The physical memory, or RAM, is like the desk space where work gets done. But sometimes the desk gets cluttered, and there's no room left for new tasks. That's where the Windows paging file comes into play. It acts like an extra storage area on your hard drive, helping your computer handle more data than the RAM alone can support. When your computer runs many programs or works with large files, the RAM can fill up quickly. The operating system then moves less used data from RAM to the paging file. This frees up space on the desk for active tasks, keeping your system running smoothly. Without this process, your computer might slow down or even crash because it runs out of memory. The size of the paging file matters a lot. If it's too small, your system will keep trying to increase its size during use, causing delays. These delays happen because the computer has to fetch data from the hard drive instead of RAM. This is called a page fault, and too many of these can make your computer feel sluggish. To avoid this, it's recommended to set the paging file size to about 1.5 to 4 times your physical RAM. For example, if you have 8 gigabytes of RAM, your paging file should be between 12 and 32 gigabytes. Another factor that affects performance is fragmentation. When the paging file expands, it might get broken into pieces across the disk, making access slower. To prevent this, it's best to pre-allocate a fixed size for the paging file. This keeps it stored in one continuous chunk, which speeds up data retrieval. Using faster storage devices like solid-state drives instead of traditional hard drives can make a big difference. Solid-state drives have lower latency, meaning they can read and write data much faster. Placing the paging file on an SSD can significantly improve overall system responsiveness. In short, the Windows paging file is essential for keeping your computer stable and responsive. It extends your physical memory, prevents errors, and helps manage memory more efficiently. Properly sizing the paging file, avoiding fragmentation, and using fast storage options are key steps to optimize your system's performance.